Good morning, my name is Jalen. I'm in 8th grade from Young Middle Magnet, and my weather question is, how does air pressure impact the weather?
And we talk about pressure all the time, don't we? Thank you for that question. So let's talk about this. What is air pressure? What in the world do we talk about when we talk about pressure in the atmosphere? Literally, the atmospheric pressure is the force from the weight of the atmosphere on us here on the surface. So as you get closer to the surface of the Earth, the pressure increases because there's more air on top of us to push down on us here on the surface of the Earth. And there's these areas of low and high pressure that cover the entire globe. It just depends on how the Earth is heated and cooled based upon different conditions on the ground. So rising air creates areas of low pressure. As the air rises, you get this area of low pressure, and the opposite is true when you have sinking air. So sinking air creates these areas of high pressure. So combined together, air will naturally flow from areas of high pressure to low pressure. That's actually where we get our wind. It's that natural flow from high pressure to low pressure. But within those areas of low pressure and high pressure, rising air is what supports clouds and storms. And if you think about your water cycle, everything rises, it cools, it condenses, and it eventually precipitates. And in areas of sinking air, that suppresses that weather development, suppresses cloud cover. And that's actually what we have in control right now, that high pressure system bringing all the sunshine.
That air pressure will always go from high levels to low levels. High levels to low levels. So think about opening a soda can. All right, when you open that soda can, you hear that pop. All right, I guess I should call it a can of pop, shouldn't I? That can of pop has high pressure inside because of the carbon dioxide, and when you open it, it releases the gas, right? Because it has high pressure inside, low pressure outside. Same thing happens inside your lungs, right? As well. When you breathe out, your lungs actually get squeezed, which pushes all the air out. And then when you open your mouth out to breathe, it feels like you're sucking in, but actually what's happening is you've got low pressure inside and high pressure around the atmosphere. And is that high pressure is just going to flow into your lungs to fill your lungs up because there's low pressure in there. Or if you ever squeezed a bottle and put it into the water and then released it, and then water will be pulled inside, that all works in a similar situation where things in air will always go from high levels of concentration, high levels of pressure, and then move to low levels as well. So let's go ahead and take a look at this. This right here is just a little simulation. If you've got a high pressure and you have a low pressure. All right, high pressure is always going to be pushed away because it's like all smashed together, and low pressure doesn't have much stuff, doesn't have much pressure, so it's always going to be pulling. Because remember that we're trying to get to equilibrium, which means everything's equal. So the high pressure really wants to share until it's equal with low pressure. All right, and if we look at this from the side, just like we saw in the video, is that high pressure is you're going to see that air is going to be pulled down. Right, it's going to be pulled down, and as it pulls down, it's going to remove air and moisture from the atmosphere, where upper up in the atmosphere where you'd have clouds, and that's why we see clear days. And we're going to see cloud. You can barely see it here. You can see clouds here because the low pressure is going to happen when we have rising air creates clouds, and as this air rises, something's got to fill its place, right? And that right here. All right, is everything rushing in to replace that air, which is that low pressure. Now, our weather actually doesn't look like this because of something called the Coriolis effect. And the Coriolis effect is something we're going to learn about later. I don't want you to worry about it right now, but what I do want you to understand is that's what causes this spinning motion, right? And that high pressure is going to be pushing air away from itself because there's just everything's all jam-packed, right? And as it gets pushed away, it turns and kind of spins away. And this is what we call clockwise because this is the way a clock goes. It goes around a circle here, where low pressure moves counterclockwise, right? And it's pulling towards itself, but it's pulling in the opposite direction, right? If we look carefully, we have clockwise this way, and the low pressure is moving in this direction, which is counterclockwise. And as this high pressure moves to the low pressure, because remember it wants to balance out, it's going to kind of make this sweeping S-like motion, all right? as that pressure gets to here, and then what's going to happen is it's going to then be pulled up into the atmosphere. All right. So what does this look like in the atmosphere? Well, right here we have this is a weather map on a loop, and this is from Monday into Tuesday. All right, so right now I want you to look very carefully right in this location right here. And if we run it all the way through, we can just see this is the clouds and the movements of those clouds, right, over basically a day, a little bit more than a day. All right, I want you to watch them as it moves, all right, as it all moves around. Now, what I want you to think about and I want you to focus is right here. I want you to focus right here. I'm going to go back, all right, and I want you really to focus here in the Great Plains, United States. And I want you to focus on what's happening to the clouds, and I want you to predict what type of pressure system do you think is happening right here. And so we can see, are the clouds getting bigger? Are there lots of clouds? Or are there not very many clouds? And what direction is this movement? And what direction is this movement? Okay, great job. Hopefully you said low pressure because we see it moving. We see cloud formation and we see this spinning that is going counterclockwise. And if you look over here, you're going to have some high pressure over here because as you can see, we're going to see this S motion, right? That as this air gets pushed away from the high pressure, right? So you pulled towards the low pressure here, pushed away from the high pressure here. We're going to see this S motion as we go into probably another low pressure system here. And if you look here, this part here, okay, is moving counterclockwise, right here, all right. And this is what is happening, and this is what meteorologists use to predict what's going. Remember, our big picture idea is that these air masses are pushed by high and low pressure, going from high pressure to low pressure, right? And that high pressure, low pressure is what moves these air masses as they interact with each other in lots of different ways and causes differences and changes in our atmosphere, in our weather, and allows meteorologists and you to predict what's actually happening. All right, so what's next here is not any questions. This is a website your teacher is going to give you for a little simulation to try and predict what kind of wind would happen as we look at high levels and low levels of pressure. So when you go to the website, there's a little cartoon. You should click through here, and it talks about how understanding weather could help you be more productive in doing something, even as silly as building a tower and winning. All right, and so what you're going to do is different levels. So if we go to level 1, what's going to happen is you're basically going to have a high and low pressure, and you can see the low pressure is pulling air into it as it's moved up towards us, basically. And that's going to cause air to be pulled towards the low pressure in this counterclockwise motion. And the high pressure is going to be pushed from above, and that's why these pieces are scattering. And they're scattering in this clockwise motion, which is with high pressure. And so what you're going to do is the white line just shows you where the wind should be. And if I move it around, you can start to see this red line move. This just tells us what is the wind doing. So if I see these so these little dots are pushing across here to the right. So if I move it here, you'll notice what happens is the arrow moves there. And the faster it's moving, the more wind it is. So what you're trying to do is you're trying to get your arrow to match the same. So start to move around, and when you see it turn green, hold it, and congratulations, you predicted that, and then you can go on to the next level, right? And then you're going to do the same thing as you move around, and I'll let you explore this on your own. At one point, it's going to ask you to move the pressure systems around. So if you have questions or comments, go ahead and ask your teacher. For that, there should be a question on Google Classroom for you to answer after you finish this. To really just take a second and think, Okay, what did I learn about air pressure and how air pressure moves from high levels to low levels, and that helps push air masses and helps those air masses interact together, causing weather, and allows us to predict what's going to happen in the future. So have fun, good luck, and we will see you next week.